Good morning, students. Today we are going to discuss about the subject Applied and Digital Electronics that you have in your fourth semester. Today's topic of discussion is Unit 1, Classification of Power Amplifiers. On the basis of mode of operation, that is for the how much portion of the output cycle you are going to get, the power amplifiers can be classified into four categories: Class A, Class B, Class AB and Class C. Which are the Class A amplifiers? Class A amplifiers are the ones where you get the output for the full 360 degree of the input cycle. That means the current flows in the output cycle in the collector circuit for the full duration of the input cycle. In Class B amplifiers, what happens? The output current flows only during one half of the half cycle, that is the positive half cycle of the input signal, and for the next of the half cycle the output is clipped off. That means there is no output in the output circuit. The Class AB amplifier is actually an amalgamation of Class A and Class B amplifiers. In Class AB amplifiers, what happens? You get the output for more than half cycle but lesser than the full cycle. That means the mode of operation in the output cycle is more than 180 degree but lesser than 360 degree. In Class C power amplifiers, what happens? The collector current, that is the output current, flows for lesser than the half cycle. That means it is even lesser than 180 degree of operation. Now let us discuss each of them one by one. Let us start with the Class A power amplifier. Class A power amplifier has an outstanding capability of actually giving an exact replica of the output that is there given in the input. As a result, what happens? The fidelity of Class A amplifier is very good. What is fidelity? Fidelity means the ability to produce an exact replica of the input. But the problem is that the Class A amplifiers have very poor efficiency. Now why they have very poor efficiency? Because the active elements, that is the transistors, remain forward biased for the full time of the input cycle. As a result, some current flows through them even when there is no input signal, and that is why the efficiency of Class A amplifiers is actually not very good. Now if I show you the output characteristics curve of a Class A amplifier, it looks something like this. If you draw the AC load line curve of a Class A amplifier, where in the x-axis I have the collector to emitter voltage and y-axis I have the collector current, you can see from this characteristics curve is that here the full 360 degree of the input is given in the input cycle, and in the output you are also getting the full 360 degree of the output. That is exactly the operation of a Class A amplifier, where you get exact replica of the input cycle. So that is why the ability to reproduce the input cycle is very good, that is the fidelity is very high. Now let us discuss about the advantages and disadvantages of Class A amplifier. The Class A design is one of the simplest out of all the types of power amplifiers, and of course, as I have told you, they have very good fidelity rate. And what is fidelity? Let me tell you once again. The fidelity is the capability to produce an exact replica in the output of the input cycle. That means exactly the output is equal to the, or the graphical reproduction of the output is exactly equal to the input graphical cycle. Now also they have also few more advantages, as because the active device, that is the transistors, remain on for the full period of the cycle of operation. That means we need not to switch on and switch off the circuit again and again. What happens as a result of that? We get very high frequency response, because if you just keep on switching and switching off a transistor in a very high speed, what happens? Some amount of frequency is lost. That is why the frequency response curve of the Class A amplifier remains very good. Also, there is least amount of distortion in Class A amplifier. Why? Because we get an exact replica in the output as of the input. That means the device conducts for the full duration of the input cycle. That is why the crossover distortion is minimum in Class A amplifiers. And also the kind of Class A amplifiers are actually the only one active transistor actually used. That means they are actually single-ended configuration can be actually used in Class A amplifiers. Now let us talk about disadvantages of Class A amplifiers. The biggest disadvantage of Class A amplifier is the efficiency. They have actually very poor efficiency. As I have already told you, they remain switched on for the whole duration of the cycle. That is why the efficiency remains very poor. And for improving the efficiency, you need to use transformer couplings like that. As a result, also what happens? The frequency response deteriorates. So it's actually a double-edged sword. Now if you want to actually use very powerful Class A amplifiers, they become very costly and bulky. due to the large power supply and also due to the requirement of numerous numbers of heat sinks. Now let us talk about our class B amplifiers. Class B amplifier is somewhat an opposite of class A amplifier, where the fidelity is lower but the efficiency is higher. Okay, the normally class B amplifier has an efficiency of around 78.5%, although this is theoretical, but the practical efficiency is actually lower than that. What happens in class B amplifier? Class B amplifier gives a conduction for only 180 degree of the input cycle. That means you can see in this graph that if I again draw the DC load line of a class B amplifier, you can see that I have given AC input in the input cycle, a sinusoidal input, but you are getting an output for only the positive half cycle and the negative half cycle is clipped off. That is why what happens, the distortion remains very high in class B amplifier, although the efficiency becomes larger than class A amplifiers. Now let us discuss about the advantages of class B amplifier. Of course, the efficiency is much higher in class B amplifiers than compared to class A amplifiers. The push-pull mechanism that is used in class B amplifiers, that can be used for that can be helpful for avoiding the harmonics. And also there are no DC components in the output. Of course, although it is also in ideal case, but in actually practical case, there may be some presence of DC components in the output. What are the disadvantages? The biggest disadvantage of class B amplifier is distortion. Due to this clipping off of one of the half cycle, what happens? You cannot get a good fidelity in the output. As because the fidelity is low, the distortion becomes very high. Also, there are also requirements of coupling transformers in class B amplifiers, which actually increases the cost and size of class B amplifiers. It is also a problem to find ideal transformers for class B amplifiers, because the transformer coupling which is required for class B amplifiers, that actually produces another problem, that is the humming noise in the output, and that humming noise also affects the frequency response of the class B transformer in the lower frequency range. And so this transformer coupling is not practical for huge loads. Now let us discuss about the last one, that is the class AB amplifiers. As I have already told you, there is a trade-off between class A and class B amplifiers. What are the advantages of class A amplifiers? Class A amplifiers have very high good fidelity, but they have poor efficiency. And what are the advantages and disadvantages of class B amplifier? Class B amplifiers have high efficiency, but they have very poor fidelity. So to make a balance between this efficiency and fidelity, we can design a class AB amplifier which has a fidelity and efficiency which are in the range of that is acceptable to us as a designer. What happens in this case, the transistors are biased in a very slightly. What happens as a result, that the conduction angles actually remains more than 180 degree, but it remains less than 360 degree. That means it is an amalgamation of class A type and class B type. If you see the response curve of a class AB amplifier, you see that here the input is given as a pure sinusoidal waveform in the input of the transistor, and in the output you get something like this, where you are getting only the full positive half cycle and a rest some part of the negative half cycle, and the rest of the part of the negative half cycle is clipped out. That means the conduction angle in the output is more than 180 degree but lesser than 360 degree. This is what a class AB amplifier achieves. That means it is more efficient, but also the fidelity is also acceptable. That means the distortion is also acceptable. So both of the advantages of class A and class B amplifiers can be actually amalgamated in class AB amplifiers. Now let us talk about the advantages and disadvantages of class AB amplifier. Obviously, there is no crossover distortion. Of course, you do not require the coupling bulky transformers that are required, and as because the third advantage is actually a byproduct of the second advantages, as you are not using any coupling transformers, there is no humming noise in the output. Now what are the disadvantages? The disadvantages are that the efficiency is slightly less compared to the class B amplifier. Of course, you need to trade off that, but there are other advantages like you get a good fidelity, and there will be some DC components present in the output as the load is directly coupled. Now if you use capacity coupling, that can eliminate the DC components in the output, but it is not practical in case of heavy loads. So some amount of DC component remains present in the output of class AB amplifiers. Now let us talk about the fourth one, that is the class C amplifier. Class C amplifier is something which gives an output even lesser than 180 degree. That means if you are giving a sinusoidal input 0 to 360 degree input in the input half cycle, you will get an output which is even lesser than 0 to 180 degree. Typically, we get an output in the range of 80 to 120 degree in a class C amplifier. Actually, this reduced conduction angle improves the efficiency, but this reduced conduction angle also creates another problem. That is, it creates a lot of distortion. And due to this huge amount of distortion, these class C amplifiers are not at all suitable for audio frequency range applications. They are mainly used in the radio frequency applications like radio frequency oscillators. Now let us discuss about the advantages and disadvantages of class C amplifier. Class C amplifier of course has a high efficiency. They are very good in radio frequency applications, and practically their size is the lowest out of all the types of power amplifiers for a particular given power output. What are the disadvantages? The linearity is very low of class C amplifiers. Of course, they are not at all suitable for audio frequency applications because they create lots of radio frequency interference. And it is also very difficult to obtain ideal inductors and coupling transformer for using in class C power amplifiers. And last disadvantage is that it reduces the dynamic range. Let me discuss about this. What is the dynamic range? The amount of frequency range that can be processed by the amplifier, that range actually gets shorted because of this class C amplifier, because the output you do not get in the full 0 to 180 degree or 0 to 360 degree conduction angle, because the conduction angle remains in between 80 to 180 degrees. So what happens, some amount of frequency in the lower frequency range and also in the higher frequency range actually gets clipped out. As a result, the effective dynamic range of frequency that you can process, that you can amplify by using a class C type of power amplifier gets reduced. That's all for the day. Thank you very much.